first model's already filled out for us. Looking at our model, y'all need to put phones away. Where did x squared plus x minus 12 go in the model? There's nothing on the top. Inside, in the center. Okay, if you have in the center x squared minus 3x plus 4x minus 12, what does that simplify to?
X squared 1 x squared plus x
minus 12. So it went in the center of your model. B, where did x minus 3 go? Left side. That's our divisor. So if that's where everything is located, where would the answer go? On the top. It closely mimics long division, right? If I had 186 divided by 3, the number I'm dividing inside the divisor out, and then the answer on the top, right? The quotient on the top. Yeah? Okay. So if we start to divide, you can use what you have to gain understanding on what's on the top. So if I have x squared and there's an x out to the left, what has to be on the top? X, because x times x is x squared, right? And so then x times -1, negative x, x times -1, negative x, that all makes sense. Now I go out to the side and I have 4 x's and there's an x on the left-hand side, so what does this have to be? 1. How many of them? 4 ones. So x squared plus x minus 12 divided by x minus 3 is x plus 4. Okay. So you just identified where everything belongs. Now we need to start from scratch. If you are dividing polynomial, when you start, your most important piece is your divisor. Yeah. So x plus 1 in this scenario is our most important piece because it's the one doing the work. X plus 1 goes out on the left. My answer is going to be on top. And that x squared plus 7x plus 6 goes inside. But I'm not going to put everything inside because if I were to go back and look at this, I probably wouldn't have set up x squared plus x minus 12 like this, just guessing, right? That wouldn't have been my first approach. But remember, it has to be a rectangle. So I know for sure that my boundary line for width is right here. I can't go any farther down than this last tile, right? I also have some sort of separation between my tiles. So let's divide. I'm going to go term by term. So I'm going to start with the leading term, which is what? X squared. Start at the top left, x squared. Do I have enough information to figure out what my first term is on top? What is it? X. Somebody needs to put their phone on silent. X. Okay. With that, just like if you were doing back to here, 186 divided by 3, what would the first things you would do be? 3 goes into 18. 6 times, and 6 times 18, 0. What's x times 1? X. I have something created from multiplying from my first step. Gabby, did you have a question? I was just showing you like the connection between dividing polynomials and dividing, how it all mimics. Okay. Y'all shouldn't be playing, you should be paying attention. X goes here. If I go and I look at my second term, I have x squared, I'm good to go there. But I need 7x. How many do I already have? 1. I have 1x, I need 7x. So how many more do I need? 6. I need to create 6x. I can't create 6 more going down, but I can from the side. So I'm going to add in 6 x's to the side. Okay, 6 x's. Is it possible for me to create 6 x's from that x out on the left? Yeah, what would be on the top? 1. How many? 6. Okay, if I have 6 1s on the top and a 1 down on the side, what am I going to create in my empty space? 6. So now I need to double check. Do I have inside x squared plus 7x plus 6? Nothing more, nothing less. Yes, we are good. So then what is x squared plus 7x plus 6 divided by x plus 1? X plus 6.
Okay, you do one by
We're
yourself.
only on number 2. Okay? You jump really fast to that statement every time. Okay. Number 3. I'm going all the way to number 6 with y'all. So if you are still not quite seeing what I'm doing, hopefully by number 6 it's going to make a little bit more sense. Okay, just like I did on the last one, I'm going to start with the divisor. X minus 2, where does it go? On the side, x and 2 negatives. Okay, I'm only going to put the 1 boundary line this time because I know I can't go further down than this. I don't really need to draw the lines in between the tiles. I feel like with multiplication, y'all got that pretty good. Okay, so I can't go any further down than that. I need to create a rectangle. So we're going to start with our leading term that we need to divide, which is what? X squared. So what has to be my first term on the top? X. How do I get x squared from an x? Okay. So now I have to finish out this column. X times -1, negative x. How many of those am I going to have there? 2. So now I have 2 negative x's. I've checked off my first term. I need 6 negative. I already have 2, but I need 6. How many do I need? 4 negative x's. So I can't put any more in the column. I have to start a new one on the first row. I have 1, 2, 3, 4, and they're negative. So I have x on the side and I need negative x. So what has to go on the top to create negative x? -1. How many of those? 4. So now I have x squared minus 6x, but I still have this little empty space here. So I have -4 times -2. What's that going to create? +8. Go back and check. Did I need +8? Yes. So I have completed my division. So what's my answer? X minus 4.
Oh, yeah.
Okay. The two that we just did together. How is that different than the picture that we had on the first? It is.
It's 2 by. It's small. It's
Okay,
negatives.
I have exactly x squared minus 6x plus 8. I have exactly x squared plus 7x plus 6. Do I have exactly x squared plus x minus 12? No, I have x squared minus 3x plus 4x minus 12. So what's the difference? It's simplified. Hey, this one had to be simplified. There were 0 pairs in there that were created. So you are going to run into a scenario where you have to create 0 pairs. 0 pairs that cancel. So let's divide x squared minus 4 by x minus 2. Where do I start? X minus 2 on the side. Okay, then what? X squared. So what has to be on top? X. Now we multiply x times negative 1, negative x, and then negative x again. And then I can have my boundary lines, right? Negative x again. How many x's did I need though? None. So if I have negative 2x and I need no x, what has to be here? Positive 2x. So I've got to go out to the side here and say I need 2 positives to cancel out the 2 negatives. So that'll be 2 singles up on the top, which closes out your rectangle with how much?
0.
Oh,
4.
oh, negative 4. No, because you had negative 2 and you need positive 2. Okay, so what is x squared minus 4 divided by x minus 2? X plus 2. Okay. Now, every single one of those have also had a leading term of 1x squared. They're not always going to. So we're going to divide 2x squared minus 5x minus 3 by 2x plus 1. Where do I start? 2x plus 1. 1, 2, and a single. Okay. My leading term, 2x squared. You have an option. 2x squared, do you want to put them next to each other or on top of each other? What makes you want to put them vertically? Because there's 2 x's on the side. I would do the exact same thing. If I have 2 rows of x's, it's really simple for me to go vertical because then I'll only use one term on the top, right? What would that term on the top now be? X. If you would have stacked them out to the side, you would have had to put 2x on the top. And if we multiplied 2x and something by 2x plus 1, I wouldn't have 2x squared. What would I have? What's 2x times 2x? 4x squared. And I didn't start with 4x squared. I started with 2x squared, so it has to be vertical. All right. Now, what does that create here? X. So we have our 2x squared and we have 1x, but what do I need?
Negative.
Negative 5x. So what do I need to incorporate into my next section?
Negative ones on the top.
Negative 6.
Negative 6.
Okay, here's the next tricky thing about multiple x squareds. I'm not going to throw 6 x's in one row, because then I have this entire other row that I'm dealing with. So if I, let's just say, we'll start with 1. If I had an x right here, what would have to be on the top?
Negative. Or 1.
Negative 1.
Negative, oh, it's a negative x. Chase, I'm sorry. Yes, negative 1. You were on the right track and I was not. Okay, negative 1, right? What would this have to be then? Negative x. Just by the sake of what you created with the first one, right? So then what would this be? Negative 1. So for every negative 1 I put at the top, I get 2 negative x's. So how many negative x's do I need in each of these rows?
3.
3. You took the 6 basically and you divided it between 2 rows. So 3 in each. Okay, so what do I need to add on to the top?
2 negative 1.
2 negative 1. And what does that create down in this empty space that we don't want? 2 negatives. So let's double check. We have 2x squared, yes. Negative 5, yes. Negative 3, yes. What's my answer? X minus 3. Okay, you need to make one quick edit. That should be a 5 there. Otherwise, it's not going to work. Okay, it should be a 5. I want you guys trying to look at on there. 5 divided by x plus 1 is 2x plus 5. Okay, so you got lots of time that you can get this homework done, which means that you shouldn't have to take any homework home. When you get to number 4, you will hit a roadblock. Once you hit that roadblock, just move on and go to the next problem. You will not get an answer for number 4. It does not work nicely, but I will explain to you on Monday how you can make it work. But you don't want to do it with tiles.
Is it because it has a remainder?
It has a remainder.